Hello guys, my name is Kaustubh and today I'll be talking about solar photovoltaic systems and its applications. So first, what's a photovoltaic system? A photovoltaic system, also in simple called PV system or power system, is an electric power system designed to supply usable solar power by means of photovoltaics. It consists of an arrangement of several components including solar panels to absorb and convert sunlight into electricity, a solar inverter to convert output from direct to alternating current, as well as mounting cabling and other electrical accessories to set up a working system. Types of solar photovoltaic systems. Mainly speaking, there are three types of solar photovoltaic systems. So the first one is grid connected solar photovoltaic system, otherwise called utility interactive PV system, converts solar energy directly into AC. And then next, standalone or off-grid PV systems can be either DC power systems or AC power systems. In both systems, the PV system is independent of the utility grid. And the third one, the solar PV systems are integrated together with other power sources such as diesel generators or renewable sources like wind to implement a hybrid PV system. So we'll just look into each one of them one by one to have a better understanding. So the first one is grid connected solar photovoltaic system. A grid connected solar photovoltaic system, otherwise called a utility interactive PV system, converts solar energy into AC power. So at end, whatever you are getting is in the form of AC power. The solar irradiation falling on the solar panels generate photovoltaic energy, which is DC in nature. So once we get here, we get DC, and then we use a DC to DC converter. The total photovoltaic DC voltage from the solar panel is raised to a higher DC level. Then a DC to DC converter is not an essential part of the grid, but is connected to the PV system, as it can connect and control variations in the photovoltaic system and regulate DC voltage. The inverter in the PV system then converts the DC voltage to an AC voltage, which can later be used on power grids. So in here, in the grid connected solar PV system, you don't have a battery that is necessary to be used. There are no batteries used. There can be batteries used, but it's not a main thing. The next one is standalone or off-grid PV systems. A standalone or off-grid PV system can be a DC power system or an AC power system. In both systems, the PV system is independent of the utility grid. So you can see there is no utility grid here. It is given directly to the load. If a DC load is connected to the PV system, then the solar panel can supply DC voltage, or a DC to DC converter can be used to convert the photovoltaic energy to a higher DC level. The DC to DC converter boosts the PV voltage to a value that is suitable for DC loads. And similarly speaking, if AC power devices are used, the PV system utilizes an inverter to convert the DC power to AC. As you can see, there is no grid used here. There are no power grids used here. It's directly given to the loads. And there might be batteries used, yes, to store and later utilize the power or energy. Hybrid solar PV systems. A solar PV system is integrated with other power sources such as diesel generators or renewable sources like wind to implement a hybrid PV system. Depending upon the type of sources incorporated with the solar PV panels, different converters are used in these systems to convert energy into DC voltage or either AC voltage. So in a small PV system speaking, including hybrid system, a maximum power point tracker, so a MPPT is used so that the maximum power harnessed is from the PV arrays or the solar panels. So it's not a must-have component in a solar PV system, but usually having a MPPT can be beneficial or can help increase the efficiency of the whole system. So you are pulling most of the energy from the power panels. So photovoltaics have applications. So these PV systems are used in various fields. So we'll just take a look into this. So there are many practical applications for solar panels or photovoltaics, as I said, from the fields of agricultural industry as a power source for irrigation to its usage in remote healthcare facilities to refrigerate medical supplies. Other applications include power generation at various scales, and attempts to integrate them into houses and public infrastructures. PV modules are used in photovoltaic systems and include a large variety of electrical devices. So we'll just take a look at them one by one. So under infrastructure, we have solar pumps. So very famous ones. One of the most cost-effective solar application is a solar powered pump, as it is far cheaper to purchase a solar panel than it is to run power lines, right? They often meet a need for water beyond the reach of power lines, taking the place of a windmill or a wind pump usually. One common application is filling of livestock watering tanks so that the grazing cattle might drink. Another is refilling of drinking water storage tanks on remote or self-sufficient homes. Second one, under infrastructure speaking, is solar streetlights. Very famous once again. Solar streetlights raise light sources which are powered by photovoltaic panels generally mounted on the top of the lighting structure. The solar array of such off-grid PV system charges a rechargeable battery which powers a fluorescent or an LED lamp during the night. So yeah, you have your solar panel and then you have your LED light or fluorescent light, and this charges a battery which might be placed somewhere else and then later powers these during the night times. So a solar street light are standalone powered system and have the advantage of saving on trenching, landscaping and maintenance costs, as well as on the electric bills despite their higher initial cost compared to conventional street lighting. They are designed with sufficiently large batteries to ensure operations for at least a week, and even in worse situations, they are expected to dim only slightly. So that sounds amazing. In the field of power generation, we have power stations. Many utility scale solar farms have been constructed all over the world. So, especially in 2011, the 579 megawatt Solar Star project was proposed to be followed by the Desert Sunlight Solar Farm and the Topaz Solar Farm in the future, both with a capacity of 550 megawatt. So, there are proposed plans to cover areas with solar farms so that maximum power can be generated and utilized. Specialty power systems. Photovoltaics may also be incorporated as energy conversion devices for objects at elevated temperatures and with preferable radiative emissivities such as heterogeneous combustors. So, self-descriptive. Under transportation, we have solar vehicles. Solar vehicles, whether ground, water, air, or space vehicles, may obtain some or all of the energy required for their operation from the sun. Surface and air vehicles generally require higher power levels than can be sustained by a practically sized solar array. So, a battery assists in meeting peak power demand, and the solar array recharges it. Space vehicles have successfully used solar photovoltaic systems for years of operation, eliminating the weight of fuel or primary batteries. So, the second is yes, spacecraft applications. Solar panels on spacecraft are usually the sole source of power to run the sensors, active heating and cooling, and communications. A battery stores this energy for use when the solar panels are in shadow. In some, the power is also used for spacecraft propulsion or electric propulsion. So, it's surprising to know that spacecrafts were one of the earliest applications of photovoltaics, starting with the silicon cells or silicon solar cells used on the Vanguard 1 satellite, launched by the US in 1958. So, that is all. Thanks for watching.